Hey everybody, in this video, I'm going to go over the homework that was due on Wednesday. Um, the first two problems on it, as people looking at the scores had quite a bit of trouble. And from hearing you in class, you weren't sure how to do this. All right, so the question is, you are looking at the decomposition of hydrogen sulfide. So 2H2S gas being broken down to two hydrogen molecules in a sulfur molecule, all gases. The Kc, the equilibrium constant for this reaction, is 1.67 times 10 to the minus 7. Everybody had different numbers than mine, but the idea is the same. Initially, your initial concentrations are H2S is 4.4 times 10 to the minus 4. H2 is 0. S2 is 0. The question is, at equilibrium, what is the concentration of S2? All right, so this is an ice table problem. When I'm asking for equilibrium concentrations and you're seeing an equilibrium constant, that should be a signal to you that we're doing ice tables. So let's set up our ice table. All right. So we have initially H2S, 4.4 times 10 to the minus 4, 0 hydrogen, 0 sulfur. We are losing our reactant because we don't have any product, so we're going to make it. So, and it's minus 2x because the 2 in front of our compound. Therefore, plus 2x here in x. And at equilibrium, 4.4 times 10 to the minus 4 minus 2x. Again, for E, you just add I plus C. So 2x, 2x. All right. And now let's set up our K expression. K is products over reactants. So Kc equals H2 squared. And it's squared because it has the 2 in front, multiplied by S2 over H2S squared. And then once you have this, you plug in all your values. So we know what Kc is, 1.67 times 10 to the minus 7 equals, these are all equilibriums, right? When you're dealing with the Kc, that means equilibrium. So we go to our E column. So H2 at equilibrium will be 2x squared. S2, I don't know why I wrote 2 there, should just be x. It's just x divided by 4.4 times 10 to the minus 4. Now, in our E column, we have minus 2x. However, if we put minus 2x down here, it's going to become complicated. We're going to have an x cubed term and an x squared term, which we have to solve using some geometry, some calculus. We don't want to do that. Let's see if we can make an assumption, right? Remember, if your starting concentration is roughly 100 times bigger than your Kc, we can say that your starting concentration, you lose so little of it, we can approximate it as you don't lose any of it. All right. And the example I gave in class is like, imagine you have $1 million and you spent like $1. Or if you take it even further, if you have $1 billion and you spent $5, you still have $1 billion, right? It doesn't really change how much money you have. So we're saying here, we have so much starting product compared to our Kc that, it doesn't change our starting concentration. Easy way to check if your starting concentration is bigger than your Kc, because I understand seeing 10 to the minus 7, 10 to the minus 4, you might not get that. Like, how do I know that's 100? Just take your Kc and multiply it by 100. If your starting concentration is bigger than that, then you're okay to make this assumption. And again, the assumption is that your starting concentration will change so little, we're going to say it doesn't change at all. So that means on the bottom, I can just put 4.4 times 10 to the minus 4 squared. I'm basically saying this minus 2x is actually equal to 0. From there, we can solve, and we're solving for x. So I'm going to multiply each side by 4.4 times 10 to the minus 4 squared. So 1.67 times 10 to the minus 7 multiplied by 4.4 times 10 to the minus 4 squared equals 4x cubed, right? I'm getting 4x cubed because I have 2x here and that's being squared. 2x squared is 4x squared multiplied by the other x, which is 4x cubed, right? And I'm trying to solve for x. So you divide each side by 4. Then you take the cubed root of this number, and that'll give you x, right? Now, on your calculators, you might not be sure how to do cubed root. So if you raise your number to the power of 1/3, so let's say you did all this math and you don't know how to do this cubed root, you just get your answer raised to the power of 1 divided by 3, that's a cubed root, right? If you ever have to do like a root to the power of 4, you just raise your answer to the power of 1/4. That's the same thing. So that's how you solve the first problem. The big thing is you have to make that assumption that the change is small. If you don't make that assumption, you'll have a squared term and a cubed term, and you're going to have a hard time figuring out how to solve this problem. All right. Let me go to problem 2, as that one also gave people a lot of issues. So problem 2 says that you are looking at the same problem. You have 2H2S. That's going to 2H2 plus S2. For me, my Kc is 1.67 times 10 to the minus 7. And I say my volume, and these are gases, my volume is 0.500 liters. For H2S, I have 0.200, I have 0.125 moles. And for H2, I have 0.200 moles. I want to know at equilibrium, what is S2? So same problem, just set up differently. The first thing is that you're given moles in a volume. One thing I want to stress, and I have been stressing a while, whenever we do these equilibrium problems, you can see I always put brackets around my molecules. For example, Kc, let's write our Kc expression. Kc equals H2 squared. Oops, that's supposed to be squared. Multiplied by S2 divided by H2S squared, right? These brackets equal molarity. And molarity is moles divided by liters, right? So for gases, I'm just starting with moles. I'm given a volume, so I need to convert these into molarity. So for H2S, that's 0.125 divided by 0.5. Let me just do that real quick. So we have 0.125 divided by 0.5, 0.250. Yep, so that's 0.25 molar. And for H2, if you do the same thing, that's 0.4 molar. So those are our starting concentrations. It's not the moles, it's the molarity. That's what we use for our ice tables. We use molarity. All right. So starting for H2S, I have 0.25 molar. For H, I have 0.4, S2, I have 0. So now we have to decide, am I going to lose reactant or am I going to make reactant? And since I have one product that doesn't have anything, Like I don't start with any S2. Le Chatelier's principle says I have to make S2. If I don't have it there, I have to make it. So I'm going to lose reactant. I'm going to make product. I'm going to make product. One other thing that I don't think I mentioned explicitly in class yet, the products all behave the same. So if you have one product that gains, that's supposed to be X. I'm getting in that. That's just plus X, not 2X. If you have one product that gains, all products will gain. If you have a reactant that loses, all reactants will lose, right? So one side of the arrow is always negative across from. Every single molecule will be negative X in the change column, and the other side of the arrow will be positive X, right? So at equilibrium, I have 0.25 minus 2X, 0.4 plus 2X, and then just simply X. Again, we can make our assumption here that this will be 0. It will be more or less negligible in the amount that we lose. We can also make the assumption here to make ourselves easier. Here, H2 starts at 0.4, which is massive compared to KC. So just like how we said, like our reactants isn't going to lose all that much. That means our product isn't going to lose all that much either, which makes our math easier. So let's plug in our KC, our numbers, right? So KC is 1.67 times 10 to the minus 7. That equals H2 squared, which is just 0.4 squared because of our assumption, multiplied by S2, which is X, multiplied by H2S squared, so 0.25 squared, right? And so here I want to solve for X. So basically multiply each side by our denominator 0.25 squared, multiplied by KC 1.67 times 10 to the minus 7, divided by 0.4 squared. That will give you X, and that will give you your concentration at equilibrium. All right. So again, if you have questions about this, you have questions while going through the homework, please let me know. Please come and see me for office hours. I put up that anonymous question on Google Docs. Feel free to post there as well. And yeah, don't be afraid to ask questions. I won't think you're dumb or anything like that. There are no dumb questions, right? You have to start from somewhere. But yeah, please let me know if you do have questions, and I will see people sometime in the future. Have a good day.